AUVs and ROVs come in a wide variety of shapes and configurations. Here I'm going to demonstrate how to set up AUV Sim with two different types of AUVs. Firstly, here's a model of a torpedo type body with two fixed horizontal fins at the back, a thruster, a rudder and an elevator. As you can see, you have the option of two different view modes in AUV Sim. You can view the vessel as a wireframe model from fixed viewpoints in the plan view, or you can view it as a 3D rendered view. In AUV Sim, you build the model up from component parts, which are split into static body elements which don't move and actuators which do move. There are two different types of static body elements currently offered in AUV Sim, a body and a fin. So for this model, we have a static body, which is the main torpedo body, and we have two fins, one on the starboard and one on the port side. The body has mass, buoyancy, dimensions and position relative to a datum. It also has drag in 6 directions and centres of drag in 3. The wireframe view of the body is a cuboid, but different 3D models can be used for the 3D view if required. The fin has position and orientation and size. You can fine-tune the length and width to get the drag and lift that you want. Options for the actuators currently include ducted fan, fixed or swivelling, a hydroplane, i.e. a moving fin, moving ballast and a bumper. So for the torpedo we've added a thruster, for which we set its position, orientation, size, maximum RPM and rate of change of RPM per second. And the elevator and rudder are both hydroplanes, and we set their position, orientation and the angle limits and the speed of response. So for this vehicle we have 3 machinery channels: the rudder, the thruster RPM and the elevator. So we set up the socket list with these entries and configure the actuators to use them. So here we see under vehicle actuators, thruster is linked to the thruster socket, rudder is linked to the rudder socket and elevator is linked to the elevator socket. We'd like to use the wireframe in 3D view to check that we've defined the elements correctly. For instance, that the hydroplanes pivot around the correct axis. In order to do that, it's useful to set up sliders on the instrument panel which link to the individual controls. To do that, you enable console layout editing and then you right click on the instrument panel and that gives you the option to create a slider. I've already done that, and if I double click on the slider I can see the properties. So this slider controls the thruster socket and it's labelled RPM. Equally here we've got the elevator one and the rudder. So now I've finished doing that, I exit console layout editing mode. If I view from the south I can see the rudder, and if I then, so if I go into, if I reset and I freeze the vehicle, then if I look from above, you can see here's the rudder here, and if I move that you can see that it responds, and it looks like it's pivoting around the correct axis. And you can see that on the 3D view as well. Equally the elevator, which you can't, hang on. Equally the elevator, which is just in front of the thruster here. we go, up and down. In fact, if we look at this from the south, we should be able to see that. Yeah. And the thruster so that all looks good. So we can unfreeze the vehicle and allow it to move. Finally, the sensor fit. Well, that's similar to ShipSim. You select your sensors from the menu and make sure that the messages, the NEMA messages are enabled, and you've set up the error models and the position of the sensors as you'd expect. The method of controlling the simulator is again similar to ShipSim. You have the option to control it through a hardware interface or through a serial interface. Since this is an underwater vehicle, the internal controllers include controllers for the height or depth and roll and pitch. The ATD1 includes height or depth control, pitch and roll, which can be turned off and on individually. In order to use these, we need to set up the cam. So here the rudder affects the yaw, the thruster affects forward motion, and the elevator affects the pitch and the depth. So here we have rudder affecting yaw, thruster, X, elevator, Z, and pitch. With this vessel, we can't control roll. So if we've enabled the internal controller and we try and hold a fixed depth, for this vehicle we really need to be having some forward thrust. So let's get moving. Heading back to the set point, which is near the surface of 0.8. Let's get it to dive a little bit and look from the east here, zoom out. And this is obviously the internal controllers, but if you you can map the parameters that we've used on the internal one onto an autopilot controller. So that's a simple model with only 3 actuators.